Welcome back to the deep dive. This is where we take that overwhelming mountain of research, white papers, and industry news and distill it all down.
Right down to the core actionable knowledge you need to stay informed.
This is episode 348.
And we have an exceptionally dense stack of sources today. They really do capture this kind of dual focus of modern innovation.
How so?
On one hand, you have this push for unprecedented efficiency with AI orchestration. And on the other, you have teams pushing the literal boundaries of physics in adjacent sciences.
Yeah.
It's a fascinating contrast.
That's right. And our mission today is, well, it's laser focused.
Right.
We want to deliver the most critical developments from the past week and make sure you walk away with those aha moments that really matter.
We're breaking it down into 3 parts.
Exactly. First, we're digging deep into today's new updates, specifically NVIDIA's Tool Orchestra and Meta's really critical publishing deals.
Then we're going to dedicate a good chunk of time to everything else happening in AI and science. Think quantum data transfer, building on Mars, that kind of thing.
And finally, we'll shift gears and look at a handful of today's trending AI tools that are driving real-world productivity right now. So let's just unpack this and jump right in. The core AI news really seems to impact deployment strategy and, critically, cost. I feel like we're seeing this powerful, sustained shift in the industry.
Oh, absolutely.
It's a shift that says the most valuable model isn't the biggest one anymore. It's the one that manages resources the best.
That is the perfect summary of the tool orchestra development from NVIDIA research. I mean, what they've done is develop a method for training a specialized small orchestrator model.
So like a highly trained air traffic controller.
Exactly. It doesn't perform the complex tasks itself, but it supervises and manages a whole fleet of larger models and external tools.
So we're moving away from that single monolithic brain that tries to do everything and moving toward an integrated system where specialization is key.
That's it.
What are the tangible benefits here? Using this little traffic cop model versus, say, just prompting a giant LLM?
The benefits are, well, they're pretty profound in 3 areas. You get higher accuracy because it's picking the best tool for each subtask.
Okay.
You get dramatically lower costs because you aren't running a, billion parameter model for simple routing.
Right.
And critically, you get reduced latency, which is essential for any real-time application. The real insight here is the training methodology. Tool Orchestra doesn't just route, it learns how to route effectively
How does it do that?
by generating massive amounts of synthetic data about tool usage.
Okay, wait. I want to pause on that mechanism because this is where the intelligence really lies, isn't it?
It is.
You mentioned synthetic data and multi-objective reinforcement learning. For anyone listening, what does that multi-objective part mean in practice? Is the model essentially weighing a dozen competing needs like speed, cost, accuracy, and making a rapid, optimized trade-off?
That's exactly right. The multi-objective part means the small model is optimized not just for the best answer, but for the best route to that answer, given certain constraints.
It's like an internal negotiation.
It is. The developer sets the priority. So if a user prioritizes speed, the orchestrator might choose a faster, cheaper, but maybe slightly less accurate tool.
But if the priority is absolute accuracy,
Then it will select the slower, more expensive specialized model. This lets the system automatically balance capability and expense. It's achieving an optimal performance frontier.
and the method and the actual trained Orchestrator 8B model are available now so developers can start building this way immediately, it feels like a serious market shift.
It does. And for you, the key takeaway is that this is hard evidence of the industry moving really en masse toward what we call compound AI systems.
Layered, modular architectures.
Exactly. They're vastly more scalable and cost-effective than the single model solutions that dominated just a year ago.
Yeah.
It fundamentally lowers the resource barrier to deploying sophisticated AI.
All right, shifting gears a bit to market strategy and the competitive landscape, Meta just made a huge play.
He did.
Striking several commercial AI data deals with prominent news publishers. This is an expensive move, but a necessary one, right?
It's absolutely necessary. In a simplified sense, these deals ensure Meta's AI chatbot can access high-quality, real-time news updates. And, importantly, it can link directly to the partner articles and websites.
But critics are already arguing this is just a way for Meta to lock down fresh content, while potentially avoiding the heavy lifting of true journalistic ethics.
Well, from a strategic standpoint, it accomplishes credibility and quality at scale.
More so than just building their own data crawlers.
I think so. Content freshness and veracity are the currency of this AI arms race. They could scrape public data, But securing explicit partnerships means their AI is drawing from diverse, timely, and trusted sources that are less likely to contain misinformation.
So it enhances their services by ensuring the information is current and relevant.
It does. And for the content creators, it highlights their growing, recognized value in the AI supply chain.
It's meta signaling a clear multi-billion-dollar commitment to its AI.
And to attracting users who demand the most current information. They are effectively paying for freshness and legitimacy. And that is a major competitive advantage when you're going up against rivals who rely on, say, static training data.
Yeah.
Now, if we connect this to the bigger picture, the long-term infrastructure of the future, there are some equally fascinating developments happening in adjacent fields.
Okay.
And let's maybe slow down the rhythm a little bit here. These details, they require a bit more attention, a bit more explanation.
I love this segment. It's where pure science starts to dictate what's possible in the future. Let's start with a really stunning one. A materials science breakthrough from Cornell. The darkest wearable fabric ever made.
This is a remarkable achievement. They didn't just create a dark material, they created an ultra-black, flexible material. And it was inspired by the specific structure of feathers from a bird in Papua New Guinea.
Feathers that naturally trap light.
Precisely.
And when you say ultra black, what are we actually talking about in terms of performance?
It is pitch black from, well, literally any viewing angle. It reflects only 0.13% of visible light.
Incredible.
But the breakthrough method is what matters. They started with simple white wool, dyed it.
Yeah.
But the key step was using plasma etching to transform the surface.
Can you explain what plasma etching is, just in this context?
Essentially, they hit the fabric with a highly energized plasma, so an ionized gas, and it acts like a microscopic sandblaster.
Okay.
This process creates these tiny uniform spikes and channels on the surface of the fibers. And these microscopic structures, they aren't dyes, they are physical traps. So when light hits the fabric, it just bounces around inside these tiny structures until it's completely absorbed.
Preventing it from reflecting back to your eye.
Right, exactly.
That sounds incredibly durable. And if it's easier to manufacture than something like Vandablack, the applications must be huge.
They are. Vandablack is complex. It requires very specialized conditions. This method is much easier to scale up on industrial textiles. So you can imagine next-gen solar panels that maximize absorption or military camouflage that defeats light detection. The ease of manufacturing is the real game changer.
Shifting gears completely now, from the visible to the invisible, researchers are claiming they have successfully teleported information via light in quantum networking experiments. This is the stuff of high-end spy movies.
It certainly sounds like it, but the reality is a little different. We're not teleporting matter, but rather the quantum state of information.
Okay.
They successfully transferred data across standard fiber optic cables, and they did it with an impressive 70% accuracy.
How is that even possible? What are the key technical components?
The process relies on achieving and then maintaining quantum entanglement between photon emitters. Right. They created nearly identical photon emitters and then sync their energy levels using frequency converters. You can think of it like tuning two radios perfectly to the exact same, really obscure frequency. A change in one immediately dictates a change in the other, even when they're separated by distance.
So the information state is transferred without the physical particle ever traveling.
That's the idea.
So what's the practical payoff here? Why should people care about entangled photons in a lab?
Because this directly addresses the Achilles heel of long-distance secure communication. If they can refine this process, it paves the way for a truly quantum internet. An internet where data security is rooted in the laws of physics.
Meaning any attempt to intercept it.
Any attempt by a hacker to observe or intercept the data fundamentally breaks that quantum state, and it alerts both parties instantly. It's a fundamentally new level of security.
Let's pivot from the subatomic to, well, the future of personal flight. The Polish startup Volonaut just released new footage of their air bike.
Yes, demonstrating a really smooth precision landing.
We're getting closer to personal air mobility being a reality.
We are. The footage showed an impressive degree of stability and control during the descent and that final touchdown. And the air bike is a marvel of material science in itself. It's a single-seat craft built around a lightweight 66-pound carbon fiber frame.
Powered by multiple jet turbines, that frame is astonishingly light. But what are the current limitations? What's holding this back from, market saturation?
It's energy density.
So, endurance.
Exactly. The current flight time is limited to about 10 minutes per tank of fuel, That's enough for quick point-to-point hops, but it raises immediate safety and logistical concerns.
Short ranges, refueling infrastructure.
And before we see these in production, Volanaut and their competitors face a very complex, very costly maze of safety certification and, critically, securing airspace regulation approvals from global bodies. The tech is advancing fast, but the regulatory framework is struggling to keep up.
Finally, let's talk about permanent expansion into space. Italian researchers have proposed an innovative and incredibly cost-effective solution for building on Mars.
This is the bioconstruction plan, and it's just brilliant in its resourcefulness.
So the plan is to bypass the monumental cost of shipping heavy construction materials off-world.
By using two specific species of bacteria that are known to survive in harsh Mars-like conditions.
Okay, so the bacteria survive the low pressure and temperature. But what's their job in the construction process?
They are the cement mixers. These bacteria are selected to secrete specific enzymes when they're introduced to the local Martian soil, the regolith. And these enzymes act as a powerful binder. They rapidly crystallize the loose soil particles into solid, durable construction blocks.
The significance here must be purely logistical then. If this works, it changes the economic model for colonization overnight.
Exactly. The complexity isn't just surviving on Mars. It's producing a material that is structurally sound enough to withstand Martian temperature swings, pressure changes, all without water. If they can crack that, it would significantly slash the logistics and cost of building a settlement. It makes large-scale colonization much more feasible.
Okay, let's pivot now and bring things back to Earth and the immediate practical applications of AI. We're returning to a slightly faster pace for this segment as we analyze the tools and services making an impact right now.
And instead of just a long list, let's focus on the biggest themes in the trending tools this week.
Which are?
Creative automation and data infrastructure. These are the applications turning research into instant productivity gains for you.
Let's start with creative automation. The standout here is CyberCut AI. We've seen dozens of video editors, so what makes this one a trending topic?
CyberCut AI isn't just an editor. It's an AI video studio designed specifically to produce viral social clips. It focuses on format optimization.
So the AI doesn't just cut the footage.
Right. It understands the rhythm, the pacing, the visual cues you need for short-form content to succeed on specific platforms. It automates those complex post-production decisions that lead to high engagement.
And complementing that is Trojan AI. This seems to take AI video a step further, focusing more on communication and presence.
It does. Trojan AI is bringing AI to life by generating these ultra-realistic, human-like video agents. We're moving beyond flat avatars to agents that can deliver complex scripts and interact with users in a way that feels genuinely personal. Huge for customer service.
Shifting to infrastructure, for those managing complex data stacks and trying to keep them secure, Pilar is trending hard. What is its main function?
Pilar basically solves the connectivity problem. Its core function is to securely connect an organization's entire data stack, which is often siloed to any modern AI agent.
This lets them leverage their own proprietary data in AI.
Without exposing the underlying architecture or compromising security, it's the essential secure pipeline.
And finally, looking at workflow automation, we have task-based Genesis. This seems to be about building bespoke live environments, not just executing single tasks.
Precisely. Task-based Genesis allows users to build sophisticated live apps, complete with autonomous agents, memory functions, and complex workflow automation. Instead of coding an application, you're instructing an AI environment on the desired outcome. It dramatically lowers the technical barrier for creating custom business solutions. That was a tremendous look at the state of the art. I mean, we covered that crucial economic shift toward compound AI systems with NVIDIA's tool orchestra.
Proving that strategic management is now more valuable than brute force size.
And we also reviewed Meta's strategic partnerships for ensuring AI content is timely and relevant.
And we dedicated time to those radical scientific leaps from the ultra-black materials and teleported quantum data to the bioengineering required for off-world construction.
So what does this all mean for the bigger picture?
The final thought I want to leave you with is about convergence. We've seen the sheer efficiency gains offered by tools like Tool Orchestra in optimizing complex systems. Now, imagine when that AI efficiency is applied directly to the development and scaling of the materials we just discussed.
Like optimizing the plasma etching process for the fabric.
Exactly. Or dynamically managing the bacterial growth for Martian cement production. The next decade won't just be about models building smarter answers. It will be about intelligent systems building a fundamentally different and far more efficient physical world.
Fascinating.
Thank you for joining us on this deep dive. If you found this information useful, please make sure you follow and share this content so others can catch up quickly too.
Until next time.
See you in the next